Today the discussion is going to be centered around the unit circle. And basically a unit circle is a circle having a radius of 1. So this is 1. Along the circle you will have some value for x and y no matter where you are. If you're here, 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 no matter where around the circle. Now what I've done is I've created a little triangle going from a point on the circle down to the origin, so it's raised in standard position here, and this triangle is going to represent a y and an x value given some angle theta. Now we know, since we've created this triangle, we have sine, cosine, and tangent ratios. Normally our sine ratio is equal to the opposite side, so in this case over the hypotenuse, which is the radius, which in this case is 1. So for the unit circle, we can say that the sine value of an angle is equal to just y. Likewise, if I look at the cosine value of some theta, that's the adjacent, which is x in this case, over the radius of 1. So the cosine of theta is just equivalent to x for the unit circle. And if it's any other circle having a different radius, we can just say it's y over r or x over r. No big deal. We've already done that before. Now what we're going to do is we're going to take and split our triangle up in a couple of special triangles that we talked about in the previous lecture. We're going to first say, all right, well, what happens if I have a theta value of 60 degrees or a theta value of 45 degrees or a theta value of 30 degrees? What are my x and y coordinates going to be? Well, if you remember, I believe it was yesterday's lesson or the day before's lesson, we know that the sine of any 60-degree angle is equivalent to root 3 over 2. So that's the y value. The cosine of any 60-degree angle is a half. In the 45-45, we found that if we have a sine value of 45 degrees, that was equivalent to root 2 over 2. And the cosine value was also equivalent to root 2 over 2. And for a 30-degree angle, we found that we had a cosine value of root 3 over 2 and a sine value of a half. So what we can do now is we can take a look at our unit circle and say, all right, well, if we have our 60, 45, and 30 with the following values, root 3 over 2 and a half, root 2 over 2, and root 2 over 2, and a half, and root 3 over 2. If I have those x and y values, then I have a ton more, because I know that all circles are symmetric about a number of different axes. If I were to take and flip each one of these points over the y-axis, I would have points of symmetry once again. This point would flip over to this point here and thus be 30 degrees away. 30 degrees away is 150 degrees. 45 degrees away is 135. And 60 degrees away is 120. Now, I have these angle values, and I also have their xy values, but in different quadrants. So this is negative half, root 3 over 2, negative root 2 over 2, and root 2 over 2, and negative root 3 over 2, and a half. So these are all x and y values, or, if you will, sine and cosine values, because I have a unit circle. And once again, I could flip all these points over the x-axis and get more values for x and y. Let's also remember that at the edge of each quadrantal angle, I have a radius value of 1 to deal with. So this is the point 1, 0 at 0 degrees, 0, 1 at 90 degrees, negative 1, 0 at 180 degrees, and at 270 degrees I have 0 and negative 1. So we can find a number of different points on this unit circle, and these points also reflect sine and cosine values for a number of different angles. So let's look at the whole unit circle all filled out. This picture gives you all sine and cosine values for important measures on the unit circle. And notice all these important measures are in multiples of 30 degrees and 45 degrees. This you're going to need to know well. And I would suggest you copy this down as you see it and retain it, or at least know how to get these numbers so that you can regenerate this at any given time. And once again, we generate these numbers by looking at 30, 60, 90 right triangles and 45, 45, 90 right triangles with a hypotenuse of 1. So what we're going to do now is we're going to find specific values for sine and cosine on the unit circle, not using a calculator, because we can use a calculator to do this, and I'll show you how to do that in a couple of minutes, but we're going to answer these questions without a calculator. Let's take a look at our first example. It asks for a cosine of 90 degrees. Now, every time we do one of these problems, we want to first ask, where are we on the circle? So where are we on this circle? At negative 90 degrees, we would be right down here. And what are the points that I have at this axis? Well, we talked about that before. That's 0 and negative 1. And in order to find a cosine value, I need to know which point I need. So the point that I need is my x value. So the cosine of negative 90 is the x value on the unit circle, which happens to be 0. Now I want to find the sine of 210 degrees, and we'll go through these three questions again. 210 degrees is in the third quadrant. At 210 degrees, I'm roughly 30 degrees away from 180. I know my x and y values there are root 3 over 2, negative, and negative half. Since I'm looking for sine, I need my y value. Therefore, the sine of 210 degrees is equal to negative half. Let's go to the next example. Next, we need to find out where the cosine of 855 degrees is. Well, let's think about that. First thing we need to know is that at 0 degrees is where I'm always starting. When I go all the way around, I'm at 360. If I go around again, I'm at 720. Whoops, 720. And if I take 720 degrees away from 855, I end up with 135 degrees left. So that really puts me right here at a 135 degree angle. Now I have the x and y values at 135 degrees, which means I also have the sine and cosine values at 135 degrees. I have a negative root 2 over 2 and root 2 over 2. And if I'm looking for a cosine value, I'm looking for my x value. So I can now say the cosine of 855 degrees is the x value in this picture, which is negative root 2 over 2. Next, we're going to find the secant of negative 120 degrees. Negative 120 degrees puts me over in the third quadrant somewhere, which is also 60 degrees away from the 180 degree mark. Now, I know that in a right triangle of 60 degrees, I have a y coordinate of root 3 over 2 and an x coordinate of a half. But since I'm in the third quadrant, both these values are negative. In this case, I'm looking for the secant. So the secant is equal to the reciprocal of cosine. And when I'm talking about cosine, I'm talking about an x value. We know our x value in this picture is equal to negative 1/2. And if I take the reciprocal of negative 1/2, I end up with negative 2. And that represents my secant of negative 120 degrees. Let's move to the next example. Now I'm going to find the tangent of negative 300 degrees. So where's negative 300 degrees? Well, if I go in the negative direction, stop 60 degrees short of 360, this is where I am. And notice, here's my 60 degrees short of that. If I create this little triangle and want to find the tangent of this angle right here, it's going to reflect the height and the base of this triangle. So this is like my y value, this is like my x value. Tangent is equal to the opposite, which in this case is y, over the adjacent, or x. And it just so happens that 60 degrees is coterminal with negative 300. So if I can find the tangent of 60, I'm good to go, because it's the same as the tangent of negative 300 degrees. So what I need is I need my x and y values at 60 degrees. I can do that. I know they are a half and root 3 over 2. If that's true, I take my y value, which is root 3 over 2, put that over my x value, which is a half, multiply by the reciprocal, and end up with root 3. And that is the tangent of negative 300 degrees. We're going to take a look at the cosecant of 390 degrees. I know 360 is all the way around a circle. So if I go all the way around and 30 more degrees, that puts me roughly at an angle of 30 degrees. Cosecant is going to talk about our y value. I need my x's and y's. At 30 degrees, I have an x value of root 3 over 2 and a y value of a half. We just said we're looking for the cosecant, which we know is 1 over the sine value, or in this case, 1 over my y value. So all I have to do is find my y value, which in turn is a half in this case. And then if I multiply by my reciprocal, I find that the cosecant of 390 degrees is equal to 2. Let's move to the next example. So we're going to talk about an example that's a little bit different. It's taking us actually off the unit circle. And they want us to find the cosecant of theta and the tangent of theta if theta is in standard position and if point -47 is on the terminal ray of the angle. So here's what I think about doing. I say, where's -47? Oh, -4, -7, somewhere down here. And this could be on some random circle. Let's just call it like this. And we say we're going to form an angle. Now, when I look at angles, I think about their angle relative to a horizontal axis, kind of like a reference angle. And I know that this point is at -4, -7. Therefore, that tells me it's 4 over and 7 down, both of which are negative in this case. So if I want to find the cosecant of that, we know the cosecant of an angle is equal to the reciprocal of sine. And sine is always the opposite over the hypotenuse. So in this case, I would need the hypotenuse over the opposite side. And in this triangle, what I have is I have actually the opposite side. I know that's -7. I don't know what the hypotenuse is. I'm going to have to find that using Pythagorean. So I know here's a right triangle, and I have 4 squared. I can throw the negative in there, plus -7 squared is going to be equal to my hypotenuse squared, or my radius in this case. I have 16 plus 49 is equal to that hypotenuse squared. Add these guys up. That appears to be about 65 rooted, equaling my hypotenuse. So I'm going to throw root 65 up here, and that's equal to the cosecant of my angle theta. Now let's do the same thing for tangent. Tangent, we know, is just equal to the opposite, y in this case, over the adjacent, which is x. And I have those in the problem. So I need the y value of -7 over the x value of -4. Negative over negative is positive. So 7/4 is the tangent of the angle. Similar problem, asked in a different way. It says, if the cosine of theta is 4/9, then find the sine of theta in quadrant 1. Cosine, we know, is the adjacent over the hypotenuse. So this ratio can be said to come from some triangle that's in the first quadrant that has a ratio of sides. This doesn't necessarily have to be 4 and 9, but I think of it that way. So I think my adjacent side is 4 and my hypotenuse is 9. I need to find the sine, which means I need the opposite, or in this case the y value over the x value. Again, I'm going to use this concept of Pythagorean to find my opposite side. I have 81 equals the y term squared plus the x term squared, which in this case is 16. And if I take 81 and subtract 16 from that, I'm going to get square root of 65. So actually not the square root, but 65. So then I take the square root of that, and I know y is equivalent to the square root of 65. If I need sine value, sine of theta is the opposite over the hypotenuse. The opposite side was root 65. The adjacent we don't necessarily need, but we do need the hypotenuse, which in this case is 9. So what we're going to do in every problem like that is we're going to kind of try to create a triangle and then find all of its missing sides, and from there get one of the 6 trigonometric ratios. Here's a similar problem. I know the tangent is equivalent to 5/6, but in this case my angle is formed in the 3rd quadrant. So if I form an angle in the 3rd quadrant, I'm going to put my angle over here, draw a triangle, and I know my tangent value, which is the y value, or the opposite in this case, over the adjacent value, which is x, is 5/6. So I know that in the 3rd quadrant, this measure would actually be a -5, and this measure would actually be a -6. I don't know what my radius is here, but I could find it using Pythagorean once again. I take -6, square that, add that to -5 squared, and that's going to equal my radius squared, or my hypotenuse squared. So that's 36 plus 25, which is 61 in this case. And root 61 is going to equal my radius. I need the cosecant, and my cosecant is the reciprocal of sine, and we know sine is the opposite over the hypotenuse, so I'm looking for the hypotenuse over the opposite once again. So the hypotenuse in this case is root 61, as we discussed, and the opposite side is -5. So 61 over -5 is going to be equal to the cosecant of the angle theta. Our last example is that we're given the secant. So if we're given the secant, I know that's the hypotenuse over the adjacent side, because this is the reciprocal of cosine. And notice this problem's a little bit different because it doesn't tell us which quadrant we're in. However, I know that if I have an adjacent side and my secant value is negative, that tells me my x value must be negative. So I have 2 possibilities of an x value being negative. One is in the 2nd quadrant, and one is in the 3rd quadrant. Both these triangles would have the same x value, both of which would be negative. So in this case, we're going to say -8 is that x value, and 17 is our hypotenuse. Our hypotenuse is always going to be positive because it's like the radius of a circle. So what we're going to need to do to find tangent, which we've already said is our opposite, or our y value in this case, over our adjacent, or our x value. We're going to take 17, square that, set that equal to -8 squared plus y squared. And if we look at this, this is one of our special Pythagorean triples, 8, 15, 17. So y in this case is going to be 15. Therefore, my tangent of theta is equal to 15 over -8. And this would reflect the 2nd quadrant. Or this upper triangle. But my tangent value of theta could also equal a positive 15 over 8. because I actually have two negatives. Notice, positive 15, negative 8, negative 15, negative 8. And this reflects the third quadrant answer. So I'd actually have to have two solutions for tangent if I'm not given a specific quadrant that the angle falls in. So once again, my angle could have been in the second quadrant or the third quadrant. The most important thing of the day is knowing where the unit circle points come from and what those actual points are. The quicker you memorize and know this picture, the better off you're going to be. Got some questions for you to answer, and we'll jump in again tomorrow.